Hi there, folks. Today we're looking at the law of sines, all right? There are two of these things. There's the law of sines and there's also the law of cosines. We'll save the law of cosines for another time here. Today we're just going to look at the law of sines. But really, what these do is they allow us to work with things that aren't right triangles, essentially. When you think about our typical trig ratios, they're only used with right triangles, and we can only use them when I have a right triangle, all right? And so that's where these become really important, is because these, the law of sines and law of cosines, can be used when we don't have a right triangle, all right? So when we have a right triangle, we just use the regular trig functions like we've been using. But when we don't have a right triangle, the only approach that we have right now is to just look at things like law of sines and law of cosines, all right? It allows us to use some of those trig functions in a very unique way, but we apply it to triangles that are not right triangles, okay? That's where this becomes really important, okay? Because, again, not all triangles are right triangles. If we have right triangles, well, that's great. We have lots of things that we can use for that. We have the Pythagorean theorem. We have our regular trig functions, but we need something to be able to find missing pieces when we have something that's not a right triangle, all right? And the law of sines is the easier of the two for most students to remember because it really is just a ratio. And it's a ratio between the sine of any angle in the triangle and its opposite side. And so that's what this is displaying. So when I look at this, we have the sine of A over A. Well, so angle A and A are opposite of one another. So when I kind of look at this, it says the sine of A over its opposite side. And what it's saying next is that that's going to equal the same ratio as the sine of B, the sine of this angle, over its opposite side. And that's going to be the same as the sine of this angle over its opposite side, okay? And so it's just a proportion between the sine of any angle and its opposite side. So if I have an angle, I can say, hey, the sine of that angle over the opposite side equals the sine of any other angle in here over its opposite side, okay? That's all this is saying. And, you know, when we look at it in terms of an extended ratio like this, you know, an extended proportion really in this case, students tend to get confused. But again, it's just a proportion between the sine of any angle and its opposite side, all right? That's all it comes down to. And we won't typically use it in this fashion like this. We'll only have two of these things when we go to solve, okay? So depending on what information is given from this thing, I might have the sine of one angle over its opposite side equals the sine of some other angle over its opposite side, and then I can cross multiply and solve for the missing piece, okay? For example, if I kind of look at this guy, here it says find the value of x. And once again, I have two of the angles in here, and I have the opposite sides associated with those. Really, I have all three angles because the angles inside of a triangle add up to 180, so I could easily find that missing angle if I need it, but in this case, I don't need it. And so the law of sines is, again, it's just a proportion between the sine of any angle and its opposite side. So, for example, if I were to kind of take a look at this angle right here, angle T, which is 32 degrees, basically the sine of that angle over the opposite side, well, the side that's opposite of that is x. So if I set that up as a ratio, it's the sine of that angle, which is the 32, over the opposite side, which is x. Well, that's going to equal the sine of any other angle over its opposite side. And so I look around the triangle and say, oh, I have this angle as well, angle B. So the sine of angle B, which is 32 degrees, so the sine, 39 degrees. So the sine of 39 degrees over its opposite side. Well, the side that's opposite of this guy is the 40. And that's it. That's my proportion. The sine of one angle over its opposite side has to equal the sine of any other angle over its opposite side. That's our law of sines, okay? It's a proportion between the sine of any angle over its opposite side. Okay, and now from here, I can just solve this thing. The most immediate path to solving this for most students is cross multiply, so I'm going to cross multiply. We could also use our properties of proportions there if you like doing that, although we'll still have one more step to do after we do that. And now from here, so I have x times the sine of 39 equals 40 times the sine of 32. To solve for x, I have to divide each side, because I'm multiplying by the sine of 39, I have to divide each side by the sine of 39. So here we go. I get x equals, sorry, I switched up the color there by accident. Well, this is a job for my calculator, so here we go. I've got 40 times the sine of 32. Reading can be pretty tough sometimes, and then divided by the sine of 39. Okay, and I get 33.68 for this one. And that was centimeters for this particular example. But that's it. All right, I'm solving for the missing side, but I didn't need to have a right triangle this time. I was able to do this without a right triangle because I'm using the law of sines. And that relates the sine of an angle to the opposite side of any triangle. Okay? And so when we look at that, so within one triangle, all triangles work this way, but the sine of the angle over the opposite side equals the sine of any other angle in this triangle over its opposite side. Okay? That's our law of sines. If I look at something like this guy, it says to find the perimeter. So in order to find the perimeter on this thing, I've got a parallelogram here with one of the diagonals drawn. In order to find the perimeter, I just need to find the length of each of these sides. And so the first thing I should look at is, well, since it's a parallelogram, I can jump around and find some of these missing angles. This guy has to be 115 degrees. Remember, in a parallelogram, the opposite angles are congruent. Likewise, when we look at that diagonal as a transversal, these would be alternate interior angles. This is 40 degrees right here. Okay, that has to be 40 degrees because it has to be the same as the 40 degrees over on the other diagonal, at the other corner. And then from here, I could find the missing angle for each of these because, again, really this is two triangles here. And so if I have two triangles, well, each triangle, the sum of the angles still has to be 180, just like it's always been. Okay, and so if I look at kind of FRO, again, just looking at half of that parallelogram, well, this angle would have to be at 25 degrees. And then likewise, we could do the same thing down here. We could think of it like the triangles. Or we could look at it as those are alternate interior angles. Here's my parallel lines, and here's my transversal. Okay, so the same way we found the 40-degree angles. But now I have all these different angles, and I have one of the sides. Well, I can come up with the other sides, the other missing sides here. And I only need one of these triangles. I could kind of ignore this guy down here. I really only need one. And so if I just look at this triangle and say, hey, you know what? The sine of any angle over its opposite side is going to equal the sine of any other angle over its opposite side. So maybe I would do something like, and I'm going to start with the sine of 115. And the reason I'm going to start with the 115 is because that's the only one that I actually know the opposite side for. Okay? So the sine of 115 over 17, because again, if I want to solve this, I need one of these proportions to be completed. I can't go in there with two proportions with each of them having a variable, all right? And maybe I'll call this side x and this side y. And so I did the sine of 115 over the 17, the sine of that angle over its opposite side. Well, if I wanted to find something like x, I would have to do the sine of the angle over its opposite side. If I want to use x, I have to do the sine of 40 degrees over its opposite side, which is the x, okay? And the options here, once again, are to cross multiply. You could also use your rules of proportions, and you could switch these. Most students don't like to do that. They prefer just to cross multiply. But let me show you how that, what that looks like if we switch them. So if we switch them here, now to solve this thing, I just have to multiply each side by 17, okay? And that'll cancel, and I'll just be left with x, all right? So again, it's pretty similar. It's pretty much the same number of steps, all right? So there's not really any advantage to using that rule this time, but either way, it's going to give us the same answer. And so this one, I would do the sine of 40 divided by the sine of 115, and then times the 17. And I get 12.06. Okay, but that's just one of the sides, and that was meters. I have to find the other missing side, and once again, I don't want to use the x because it's a rounded off answer, so I want to start with the proportion that I was given, all right? That proportion of sine of 115. So I still want to start with this one because that was the one that was given. That's the one I have in exact terms. Sine of 115 over 17. Well, now I want to find y, so I have to use the sine of 25 over its opposite side, which is the y. Okay, so we sine of the angle over the opposite side. And the law of sines is just that there's a relationship there where those are proportional. Okay, the sine of the angle over the opposite side is proportional to any other sine of angle over the opposite side for this triangle. Okay, and now once again I could cross multiply. I'll just cross multiply this time because I think that's what most students prefer. Again, it doesn't really save us any steps doing it the other way. And now to solve this thing, I just have to divide each side by the sine of 115. Again, that's a job for my calculator. So let's see, I had 17 times the sine of 25, and then divide that by the sine of 115. And I got 7.93. And so when we look at this thing, let me come back up here and let me erase these guys. So this was a 12.06. This was a 7.93. Again, that's meters. But now the question didn't even ask me to find the missing pieces. I needed those as a stepping stone. It asked me to find the perimeter. So let's find the perimeter of this thing. I just have to add all the sides together. And so really for this one, I'll use the rounded off answers now instead of leaving them as exact. Times 2 plus 7.93 times 2. Okay? And so when I add up all those sides, I get approximately 39.98. Okay? Meters. And we'll use the little approximation symbol, okay? About that much. And if you don't round one of these off, if you left them more exact, I might have a slightly different answer here, okay? If I look at this guy, this time I want to find the missing angle, but that doesn't really change anything in terms of my setup, okay? In terms of the law of sines, the same thing still exists. The sine of the angle over the opposite side equals the sine of any other angle over the opposite side, all right? The only thing that's going to change is what I'm going to have to run into and what I'm going to have to do as I solve this thing, okay? And so let's start with the thing that we know for sure. The one relationship that's complete would be this angle with this opposite side. Notice there's no variables there. I always like to start with the thing that doesn't have any variables. So I would say, hey, you know what? The sine of this angle, which is 27, over the opposite side, which is 5, well, that's going to be equal to sine of any other angle over its opposite side. And so now I look for what I'm trying to find. See, I have all numbers in that first proportion. Now I look for my variable. Well, that's this guy right here. And notice this time, that's the angle this time. And so when I look at this, I want to do the sine of the angle. Well, sine of the angle this time is x, okay? And then I put that over the opposite side. So right here, the opposite side is the 8. So in terms of the setup, nothing has changed here. The only thing that's going to be different is what I have to do in the process of solving. It's still the sine of the angle over the opposite side equals the sine of the angle over the opposite side. Just so happens that my unknown is the angle measurement this time instead of the side length, okay? But now I'd kind of start off the same way. I cross multiply. So if I cross multiply here, that's going to give me a 5 sine of x. I guess I can scoot that up a little bit. So 5 times the sine of x equals 8 times the sine of 27. And yeah, I could plug that into my calculator, but I'm not quite ready for that. I want to wait till the end to plug it all in, so this way I don't have as much round-off error. And now to get x by itself, well, normally to get rid of the sine, I would take the inverse sine, but there's something else that's there, okay? So I have to get rid of that 5 first, so I'm going to divide each side by 5. And I'm just going to write this as 8/5 times the sine of 27. I mean, you could leave it as a big fraction. It doesn't matter. Maybe I should just done it that way, okay? Whatever you're more comfortable with, whatever's easier for you to punch into the calculator, because that's where we're headed with this thing, okay? So what I have here is the sine of x equals this whole thing. Remember, to undo the sine function, I have to use the inverse sine function. So to undo sine of x, I do the inverse sine of this side. And of course, whatever I do to one side, I have to do to the other side. And so the next challenge here is plugging this into the calculator. If you want to try plugging this all in one shot, it's going to require a lot of parentheses, okay? What I personally like to do is I basically take order of operations out of the calculator's hand. So let's see here, those cancel. So let me just write my x. And now let me show you how I might punch this into the calculator. So for this one, if I kind of do the operations myself, I would first do the 8 times the sine of 27. So that's literally what I do, 8 times the sine of 27 degrees. And then I'll hit enter. And now I want to divide that by 5. But again, I don't want to round it off, so I just hit divide by. And notice it does my previous answer divided by 5. And now I want to take the inverse sine of that. Here's where it becomes a little tricky. Instead of taking the inverse sine and then typing that whole thing in, almost every calculator has an answer button, which basically uses your previous answer. It's almost always located at the negative symbol on your calculator. So on this one, I do second or shift, I do inverse sine, and then if I do shift and then the negative button, there it is, answer. And even the little calculators, the TI-30s, they have this feature, okay? And so basically, instead of me having to type in the 0.726384 without rounding it off, my calculator just punches it in for me, okay? And so I get a 46.58 degrees. Okay? So again, everything here is the same, all right? Except in the process of solving, I run into a situation where I have to use the inverse sine function, okay? And that always happens when we're trying to find an angle. And if you haven't realized that, whenever we're finding a side, well, that means we have the angle. We don't have to use inverse functions here. We just have to use the regular trig ratios, okay? The regular trig functions. But when we're trying to find the angle, well, that's where we're going to have to use the inverse, okay? If I look at this guy once again, I just have to set this up as a proportion. It's the, the sine of the angle over the opposite side. And again, I start with the one I know. The one I can see, the one I know for sure that only has numbers in it would be the sine of the 110 over the opposite side, which is 9. Okay? And then the other thing that I have here, now I want to find my variable. Well, the variable is the angle measurement this time, so the sine of x over the opposite side, which is 7. And now I cross multiply and solve. So here, cross multiply. Divide by the 9 so I can get that sine function by itself. And now I take the inverse sine. To get rid of the sine function, I use the inverse sine function. These guys cancel out. And now I just plug this into the calculator. So just like it did on the other one, I'm just going to kind of take order of operations into my own hands. Times the sine of 110, enter, divided by 9, enter. And now I'm going to take the inverse sine of my previous answer, enter. And I get 46.96 for this one. And that's it. If I look at the next one, cell phone pings 2 cell towers at angles of 32 degrees and 25 degrees respectively. If the towers are 30 miles apart, how far is the phone from each tower? And so, this is kind of, the idea of triangulation when we're trying to locate something. That's what this means, okay? So we're triangulating the signal to kind of figure out where it is. And so if I have these 2 towers, let's say one of them is right here, and the other one is right here. They're 30 miles apart. And so the cell phone is out here somewhere, and this tower gets a hit on it, gets a ping. This tower gets a ping on it. And basically, we can kind of figure out the direction of that thing. So basically, it's saying that this is 32 degrees, and this is 25 degrees respectively. Okay, and so now I can kind of figure out how far away this thing is from each of these towers. All right, and it asks me to find each, so I can say, hey, this is x, this is y, and now I'm just going to set up my proportions using my law of sines and solve. And so when we look at this one, again, I always want to start with the thing that doesn't have any variables. The problem is right now I don't have that angle, but once again, because I have two of the angles, I automatically have the third angle, all right? And so even though it's not written here, I know what it is. That's the angle I need to kind of start with. I need this one to complete one of these proportions. So I have to fill in this guy, which is the 123 degrees, okay? And the reason I need that is because I have to have a proportion that, I have to have one of these ratios that doesn't have any variables, all right? And that's the one I need, so it's the sine of 123 over the opposite side, which is 30. Okay, that's the one I always want to start with. And, that's kind of why I start with it. In case there's something that I need to find or something I need to adjust, now I have it. And now from here, I can find either the other ones. If I want to find x, I would use the sine of 25 over its opposite side, which is x. And now I can cross multiply and solve. And for this particular example, I don't have to use any inverses. I just have to divide each side. And then plug it into my calculator. So this one's 30 times the sine of 25 divided by the sine of 123. So I get 15.12. And then I can also do the same thing for the other set of this thing. So once again, it's sine of 123 over the 30. And then to find y, I have to use the sine of 32 over its opposite side, which is y. And once again, I cross multiply. And as you're looking at this thing, when you're doing these kind of in series, when you're doing a couple of them in a row, and it's the same example, hopefully you're looking at this going, I don't really have to go through everything that Mr. Jansen's doing right now. I could simply swap out the sine of 25 in the first example. I did 30 times the sine of 25 divided by the sine of 123. I just changed that to 30 times the sine of 32, okay? Because it's the same process each time. Okay, so if you want to take a little bit of a shortcut there, especially when you're doing a couple of these for one triangle, it's pretty easy to do that. And so I get 18.96. Okay, and the reason we would want to find the distance for each of these is because that degree measurement might not be 100% accurate. So it might not give us an exact triangle here. So it's going to give us a range of values to know where to look for where that thing is, where that cell phone is. Okay?